Hello. Today we're going to look at the hybridization of the carbon atom in our methane molecule. Of course, methane is CH4. Here's the Lewis dot structure for methane. Here's the 3D sketch of methane. And of course, we know that it's tetrahedral. It's tetrahedral. Name of the shape of it is. And these bond angles, they're all 109.5 degrees. All the bond angles are the same. What I'd like to focus on are these valence electrons, these 4 valence electrons here of the carbon atom. So we know the valence electrons are involved with the bonding. Let's remind you of a couple things from last year, from your first year chem course. Let's look at the orbital notation of carbon. We know that carbon has six electrons. So carbon has 6 electrons. 2 of these are in the 1s orbital. 2 are in the 2s orbital. And then we have the 2p orbitals. And there would be 2 in the 2p orbital. And of course, as we go this way, the energy of the electrons go up. Each of these little marks represents an electron. So we're just interested, we're interested in these valence electrons, these 4 valence electrons. Now, these electrons have different energies, but these electrons have the same energy, produce the same type of bond. So what we've realized is that these orbitals hybridize. So for example, in agriculture, we hybridize different plants. There's lots of different hybrid types of tomato plants. And so what happens is, what we have is this. We have 4 hybrid orbitals that are formed, each having 1 electron. And these hybrid orbitals, these orbitals are somewhere in between, energy-wise, between the 2s and the 2p. So what we've done is taken an s orbital and we've hybridized it with 3 different p orbitals. Now let's remind you of what a s orbital is. An s orbital is just a spherical. It's spherical. It's represents the area where you're most likely to find an electron. The nucleus would be right here. And if you remember, the p orbitals are shaped like this. There are 3 p orbitals, 1 for each axis, 3 dimensions. So what we're doing is taking an s orbital and we're adding 3 p orbitals, and what we're going to get are 4 sp3 hybrid orbitals. And so what's going to happen is there's going to be some s characteristic to this new orbital. There's going to be some p characteristic to it too. In this case, there's going to be more of the p characteristic because there are 3 of them. So what we're taking is s orbital and 3 p orbitals, and we're forming 4 of these sp3. They may look like that. That's what they look like. So this here is the s portion of it, and this is the p portion of the hybrid orbital. So let's look at how these form this tetrahedral shape. So let me see if I can draw this. So now we have 4 of these. So we know we have 1 like this. Of course, the carbon atom is going to be right there. We have 1 coming out toward you. We have 1 going into the board. And then 1 coming out here. Okay, so that's not too bad. Let me make this a little bit bigger. Now, typically, we don't even draw that. So, for now on, maybe I won't even draw the S portion of this. Now, we know that in each of these orbitals, there's an electron. So let's put an electron here, electron here, electron here, electron here. And when they bond with hydrogen, hydrogen has one electron as well. And that one electron, the hydrogen atom, is in the s orbital. So they overlap, these orbitals overlap right here. So we have methane. Maybe I could just add a couple things here. I'm not real pleased with this. Okay, so this is this is a bond, and this is a bond that occurs between two nuclei. This is the carbon atom here, and that's the hydrogen atom. And this bond's called a sigma bond. And a Greek letter for some sigma looks something like that. And so there, in methane, there are 4 different sigma bonds. 4 different sigma bonds. Let's look at ethane. Let's look at ethane and look at what that would look like. Ethane, of course, is C2H6. So what we would have is, and we know it looks like this. It looks like tetrahedral around the carbon atom. I'm hoping you can see this in the video. So we'd have a carbon atom here with a hybrid orbital here. This carbon atom has a hybrid orbital here. They overlap right there. That's a sigma bond. Then we have let's draw orbitals here, 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 and here. And each of these have an electron. And then, of course, the hydrogens bond here. And now if you look at the number of sigma bonds, we have 1, 2, 3, 4, 5, 6, 7. So here we have 7 sigma bonds. That's a typical question that could be asked of you. Count the number of sigma bonds. The sigma bonds, again, occur between, it's when the sharing occurs between 2 nuclei. Okay, we'll continue this. Next video will be on sp3 hybridization, then sp hybridization, and then a 4th video where we wrap up hybridization. Okay, thanks.